Okay, good morning, all of you. Now, let us continue with our topic, that is real numbers. Today, we will discuss the topic that is proof of the irrationality of the numbers. So, our today's topic is that is proof of irrationality of numbers. Proof of irrationality of numbers. In this topic, we will prove few numbers that they are why they are irrational. Okay, so let us come to the first topic. We solve few questions. Okay, in this our first question is prove that prove that root 2 prove that root 2 is an irrational number, is an irrational number. Okay, now let us come to the solution of this question. How we will solve this question? If we want to prove that root 2 is an irrational number, for this purpose what can we do? We can prove root 2 is an irrational number by the method of the contradiction. Okay, so let us assume root 2 be rational, root 2 be a rational number. Okay, let us assume root 2 be a rational number. Okay, now if root 2 is a rational number, that means it can be expressed in the form of a by b, means we can write root 2 is root 2 can be written as in the form of a upon b, and here the condition where a and b are co-prime, where a and b are co-prime. Co-prime means the HCF of these two numbers should be equals to 1. Okay, now if I cross multiply this equation, I will get a is equals to b into root 2. Okay, now for removing the square root, I'm squaring both sides. So next we can write. Okay, so if I'm squaring both sides, then we will get is that is a square is equals to twice of b square. That is a square is equals to twice of b square. That is our first relation. Now if you observe this equation, we can see that we have studied a very important property in fundamental theorem of the arithmetic, that if uh, it is written that a square is equals to twice of b square, it means if 2 divides a square, what can we write? If 2 divides a square, if 2 divides a square, it means what can we write? If 2 divides a square, it means 2 also divides a. 2 also divides a. Okay, this theorem we have already studied in the fundamental theorem of the arithmetic. If 2 divides a square, then also 2 also divides a. Now in the next step we can write if 2 also divides a, it means we can write a is a multiple of 2, so a is equals to 2 into k. Now if I square both sides, then a square is equals to 4k square. Okay, now this is our equation number 2. Now by equation 1 and 2, by using equations by equation 1 and equation 2, by using equation 1 and equation 2, if we equate these two equations, we can write that is twice of b square is equals to 4 times k square. It means if we cancel out 4 by 2, then we can write in the next step that is b square is equals to 2 times k square. That means we can see again in the similar way, we can say that 2 divides b square. We can write since 2 divides b square, that means that's why 2 also divides 2 also divides b. Okay, it means b is also multiple of 2. Now, from the two relations, we have already said in the above equation that 2 divides a, 2 also divides b. But in our question, we have already assumed that a and b are the co-prime numbers. Okay, it means by these two equations, we can say that 2 is 2 is 2 is a common factor of 2 is a common factor of both a and b. 2 is a common factor of both a and b. That means we can write HCF of these two numbers is not equals to 1. That's why by contradiction, okay, so we can write, but this contradicts the result, that, but this contradicts the result that a and b are co-prime. a and b are co-prime. A and b are, okay, so we can say that root 2, this means that root 2 is an irrational number. Root 2 is an irrational number. Okay, so by the method of contradiction, we have proved that root 2 is an irrational number. Now, let us solve few more questions that are again based on the proof of the irrationality. Now, we come to our second question. Okay, Hmm. Prove that 3 minus root 5 is an irrational number. 3 minus root 5 is an irrational number. Now, again, for solving this question, we will again use the method of contradiction. So let us come to the solution of this question. So again we can write, let us assume 3 minus root 5 is a rational number. Now, if this number is a rational number, that means it can be written in the form of p by q. Means we can write 3 minus root 5 can be written in the form of p by q. Now, and where p and q are, we can write here, where p and q are co-prime. Where p and q are co-prime. Where p and q are co-prime. Now, if I transfer p by q on left hand side, then it can be written as 3 minus p upon q is equals to root 5. Now, if you observe this equation, that on right hand side there is written root 5. Root 5, this number, it is, and this number is an irrational number. It is an irrational number. And 3 minus p by q, and if you observe, this 3 is a rational number and p by q is also a rational number. Now difference of two rational number is also a rational number. That means we can write left hand side is a rational number. Now, since rational number cannot be equal to a rational number, okay, so we can write that left hand side is not equals to right hand side, because rational cannot be equal to rational. That's why by contradiction, okay, the contradiction that we have assumed in our question, that 3 minus root 5 is a rational number, is wrong. So we can say, so 3 minus root 5 is a irrational number. So 3 minus 5 is a irrational number, because which is wrong according to our assumption. Okay, so by this way we can say that this number is an irrational number. Okay, so these are the few questions which are based. We can solve one more question. Let's solve one more question that is also based. Come to our next question. Okay, prove that root 2 plus root 3 is a root 2 plus root 3 is a irrational number. Is a irrational. Okay, now for solving this question, just come to the proof answer of this question. Again, we will assume that, let us assume root 2 plus root 3 is a rational number, So that's why we can write root 2 plus root 3 can be written in the form of p by q, okay, where p and q are, where p and q are, where p and q are co-prime. Now, for removing the square root, we can square both sides. So in next, we can write on squaring both sides. On squaring both sides. Okay, if I'm squaring both sides, I can return as 2 plus 3 plus twice of root 6 is equals to p square divided by q square. Now if I transfer the terms rational on rational side and irrational on irrational side, I can write twice of root 6 can be written as p square divided by q square minus 5. Now square root of 6 can be written as 1 by 2 in bracket, that is p square divided by q square minus 5. Now again, if you observe the left hand side and the right hand side, we can conclude that, okay, root 6, okay, this number root 6, this it is an irrational number, okay, it is an irrational number, and the number on the right hand side, this number, it is a rational number. Okay, so again we can see that rational cannot be equal to irrational. That's why we can say that left hand side is not equal to right hand side. So we can say that which is wrong according to our assumption, which is wrong according to our assumption, which is wrong according to our assumption. Okay, so root 2 plus root 3 is a irrational number, is a irrational number. Okay, so by this way we can prove the irrationality of the numbers. Okay, that's for today. We will continue with the next topic in our next class. Thanks.